polymerase chain reaction or PCR was first described over 20 years ago, and it is a technique for making millions of copies of the gene or a particular DNA target of interest. Copies are made using a small initial quantity of DNA template, even down to just a single DNA molecule. PCR means the detection and identification of your DNA target can be made using visual techniques based on the size and charge of the piece of DNA you have amplified. The theory behind every PCR is whenever your DNA target is the same. A mixture contains 5 bacitins, which are DNA template, DNA polymerase enzyme, forward and reverse primers, nucleotides, and buffer to stabilize the enzyme. For each new PCR, choose the primers and design them to be complementary to short sections of DNA next to or near your region of interest. Usually, they are between 20 to 30 bases or nucleotides long. The enzyme is there to extend the primers which have annealed to a specific region of the template and use free nucleotides in the mixture to build the new strand complementary to the target. The primer should only anneal to this particular region of interest.
During the PCR, the DNA being amplified is heated and the double strand separates. Upon cooling, at 72 degrees centigrade, the primers bind to the template and the process of adding complementary nucleotides by the polymerase can begin. The initial heating step is called denaturation and usually occurs at 94 or 95 degrees centigrade. It needs to be at this temperature long enough to denature the template completely. The following step, when the primers are able to bind to the template at a lower temperature, is called annealing. This temperature depends on the TM or melting temperature of your specific primers and is usually between 50 to 65 degrees centigrade. This step does not need to last very long, typically 10 to 30 seconds. The final step in this first amplification cycle is the extension at 72 degrees centigrade. This is the optimum temperature for the DNA polymerase to build the complementary strand following on from the 3' ends of the primer using the free nucleotides. The polymerase adds them at around 50 to 100 bases per second. So, the duration of this step will depend on the length of your target, but 30 seconds to 1 minute is usually long enough for most products.
Process of denaturing, annealing, and extension was repeated for about 30 to 40 times. It is theoretically doubling the number of DNA copies at each cycle and thereby increasing exponentially the number of copies of target interest in the mixture. The samples can be prepared and incubated in a thermocycler, and a complete PCR reaction can be performed in a few hours or even less than an hour with certain type of rapid instrument. The lab area used to set up and run the reaction must be carefully controlled and maintained. PCR can detect a single molecule of DNA, so it is essential to have a unidirectional workflow with ideally 3 separate rooms in system. Firstly, we need to have a clean room which contains all of the reagents for our PCR except the DNA template. None of the reagents and consumables would have been into the area where PCR products are generated or analyzed. The best system would involve a workflow where the clean room would not be revisited on day when we have been in other potentially PCR product contaminated areas. The second room in system would be the accession lab where we have been prepared a template ready to put into the PCR once we have set up in our clean room. We would take the reaction tubes or plates to the accession lab and add our DNA template. From there, we can go on to the third room, the PCR machine room. This is where the PCR takes place and where the products are usually analyzed by visualization on a gel or by other methods. It is best to consider that PCR products that we generate contaminate this third lab. However, we need to be careful by never set up PCR reaction here or take reagents or consumables from this lab into the other rooms, or they could contaminate our clean system.
The proportion of the reaction mixture have a great influence on the quality of PCR result. There was a general formula for concentration of template, enzyme, primer, and nucleotide to use, but this can be varied a little if necessary. The general guideline were 0.5 until 2.0 units of tag polymerase, 200 micromolar of each DNTP, 0.2 until 0.5 micromolar of each primer, 50 to 500 nanogram of genomic template, and lastly, one-time buffer. Conveniently, there were also PCR master mix available with all the components combined. All we need to add were the primers and template. In this experiment, we were going to use the clean system to set up 6 reaction, 3 PCR, 3 control reaction, 1 negative control, 1 positive control, and finally an extraction control. Always use negative and positive control reaction to ensure the results are due to amplification of the right sample. To make sure we have enough reaction mix to go around, we will make up enough to 7 reaction. The 6 reaction already mentioned plus 1 extra.
Usually, 1 microliter of DNA template would be sufficient for each reaction, so the reaction mix was made up to 333 microliters with water supplied with the master mix. This volume is calculated by subtracting the remaining volume to be added to the final total volume of 340 microliters. 49 microliters of the mix were dispensed into 7 labeled tubes that will fit PCR machine. The tube was taken to the extraction room to add the template DNA. Before leaving, lab coat was changed. In the extraction lab, 1 microliter of DNA template or control material was added. For a negative control, water is used. Meanwhile, a non-positive extract is used for a non-positive control, and a positive control that has been taken through the extraction procedure to control for inhibition. Tubes were closed and brought to PCR room without wearing lab coats. The tubes were placed into the instrument and cycling process started. There are a lot of instruments to be used, and in this video, a block-based instrument was used. Also, there is real-time instrument which is faster and they measure fluorescence in real time as PCR products are generated.
That's the end of our video. Thank you for watching.